two of the older people, myself included, are retiring, so four of us are going. So the group
Good evening, everyone. Good evening. A very warm welcome to SANSA Hermanus. Thank you very much for joining us this evening for what I believe to be is going to be a really interesting and wonderful talk. And I hope by the end of the evening you agree with me. I also would like to welcome all our viewers who is watching online. I know we've got viewers from all over Africa as far as Egypt who watch the series. We launched the Space Talk series a couple of years ago to really invite the community of Hermanus into our facility and so that we can share the joy and wonder of space. And so tonight I'm very honored to welcome Dr. Thomas Beer, who is he is a lawyer as his profession, and he is an expert in space policy, and he worked with ESA for over 30 years and also worked with the European Union. And I believe that space policy is one of the pressing areas that we need to look in as an African continent to really play a pertinent part in this global expansion of space. So Prof. Beer, thank you very much for coming to speak with us tonight. We look forward to the talk, and I hand over to you.
Yeah, thank you very much, Darlene. Can everybody hear me, basically? Okay, yes. Does this sound good? Yeah, first of all, thank you, Darlene, to mention that I'm a lawyer by trade. This gives me already a good excuse when some of my more technical information might not be so exact as you as engineers here at SANSA would expect it. So yes, I'm a lawyer by trade, but I have been a passionate member of the European Space Agency for many years, and what I'm doing now after my retirement is just to inform those who are interested in about space, about what we have here above us and what the universe is offering us in case of mysteries, and also in case of offering us benefits for mankind, which are easy to be identified if you have a closer look at what is going on in space agencies, for example, here at SANSA, but also at the European Space Agency, which I will talk about a little bit today. My talk is subdivided into several little chapters. I start with the latest update on space news in order to make you aware what has happened in the last weeks and months. Sometimes it has not been so much publicized here on the African continent. It was more a European issue. So I want to let you know that. I'll talk about that a little bit, and then I tackle issues dealing with the mysteries. And there we go to the mysteries of space, of the universe. Issues which you might know. If you don't know, you will get it confirmed that this is something really mysterious and hardly to understand. And this is what I am always proud of, to say that this is something which you barely can accept as a fact, but it is like that. And then we come to the benefits. I will let you know a little bit about what ESA is doing, because ESA is offering lots of benefits. And today my focus is on Earth observation, because Earth observation provides so many possibilities to benefit from space. Yeah, this being said, we just go for it. Here are the most recent space news. I have tabled 4 here. There is 1/5 space news, which I just got this morning, and I don't want to be silent on it. I didn't put it here yet. And this is the launch of the Athena mission, which happened last night in California, I think in Vandenberg, on a SpaceX missile. It was a NASA mission which was sent to the moon, Athena. And the lander, which will come out of the satellite, will be on the south pole of the moon, and it will look for ice. It will look for ice, and it's quite sure that there will be ice under the surface of the moon of the south pole. And why do we do that? Because we need ice in order to produce fuel if you want to use the moon as a jumping board to other planets. I mean, there is no way we can fly to the moon and hope that we go from the moon to Mars if we don't have the fuel available. So you can win fuel out of ice by electrolysis. So this is what they are going to do, and this is also very much in the sense of our future plans to go to Mars, because Mars is basically the only planet which is basically available for serving as a kind of refuge for mankind in case things go awry on our Earth. So this is this Athena mission which started yesterday. The other items which I have mentioned here is SpaceX, the fifth test launch of Starship. Then we have space debris, topics which are very much getting more and more interesting, but also dangerous, because we are hammered by space debris every day. And people might ask themselves, what happens if space debris crashes on my front porch and kills my cat or something like that? We also have to be happy about seeing a disabled astronaut joining the ESA astronaut team. I will talk about it in a minute. And we speak about this famous asteroid, which was in all newspapers a couple of weeks ago, I think, which might impact the Earth in 2032. And I'll let you know a little bit what is the latest on that. But let me first go to this little video which shows the launch of the giant Starship from Texas, from the coast of Texas, and which had this magnificent success by returning the booster to the launch pad. And I just want to show it to you again, because it's just an amazing event. I couldn't believe my eyes. It is a project from Elon Musk. You can say what you want about him, but this is just a great success, what he did there. It's just amazing. Even our launcher people at the European Space Agency, they were just so happy. Could we launch this video? Here we go. So we see the huge Starship on top of the
Best work you could
booster.
possibly hear 20 seconds away from liftoff.
Here we go. Yeah, this is the Starship, which will host, once everything goes well, up to 100
T-5,
people.
4,
100 people
3,
will go into
2,
this Starship.
1.
And this is the booster which will now boost up the Starship into space.
We have liftoff.
Vehicles pitching downrange.
And as I told you, there is not much we can choose amongst the planets where we want to go. We have 4 rock planets: Venus,
Booster and
Mercury,
pressure nominal.
Mars, and the Earth. All the other planets are gas giants, so we cannot
30
go there.
seconds
So
into the flight,
going
the
to Mars
Brussels
would
just
be
starting to
okay
reach us
if we
here
had the right
at launch
transportation
control.
system. And this is one. This is the only one which would allow us right now, if it's getting in perfect shape,
Booster
to go to Mars.
avionics power,
And
telemetry nominal.
33 Raptor engines.
here you see it going up into the low space
Max
orbit.
Q.
Now pass through the maximum
At a
aerodynamic
certain
pressure,
stage,
the
there will
most
be a
stress the vehicle's
separation
going to
of
see on the way
the
uphill.
of the Starship and of the booster.
All right, our next major milestone coming up, it's going to be hot staging. We're going to see the engines ignite on ship to push it away from the booster.
Before that 5th launch, there have been 4 other launches which failed, which did not produce the result. But this is how the Starship technology works. The engineers work by failure. They just go on, they learn from the
So hot
mistakes,
staging
and
is going to
they
be the next
just
thing coming up.
produce
First, we're
the
going to
next
see the booster's engines start to shut
model
down.
of the technology
All
to be
but
tested.
3.
This would never
We're
work
going to do
in
what's called
other
most
space
engines cut
agencies,
off.
like
Instead of
the
main engine
European
cut
Space
off, is 3
Agency.
are
We
gonna
don't
keep
have
going.
this approach.
And then we're going to see the engines on ship ignite. Right now, the tower team is doing their go, no go.
Here we go.
And we might hear some really good words soon, too. All right. Can still see it up behind me. That is one of the most gorgeous things I've ever seen in my entire life. Coming up on hot staging next.
This was the separation.
Those engines cut off.
Here we go. It's flying away. This is the booster, which is now addressing itself towards the Earth.
Hot stage
And the Starship continues its flight. It will land a bit later in the ocean.
Power, I'm seeing 6 out of
But
6
the controlled
Raptors
landing will be
Hopefully I got a booster on the way back to me. I'm going to send it to you guys in Hawthorne.
Forget everything you knew about war games. The large-scale action game War Thunder will bring you a storm of unforgettable.
Here we go.
Oh man, that was absolutely incredible. I loved how the crowd
Chamber pressure is nominal.
crowd here in Hawthorne all went ooh at that first view of the blue flames from the booster. As you can see there, first stage currently performing, or excuse me, is now making its way back to the launch site. Again, we are.
Ship avionics.
So basically now the booster is falling back to the
booster and the tower are both performing
Earth.
automated checks to make sure we are go for the booster to return
produce some
to the
very
launch
specific
pad
maneuvers
for that catch. And once
in
those
order
are
to
complete, the
allow
flight director
a vertical landing by using its Raptor rocket motors.
And we did hear that the tower is go for catch, so
And
that
to
was
hear
one of
how
the
people
big
are
criteria
excited,
we were looking
they are all
for.
standing on the beach there and they are cheering this.
this view
We'll
here.
wait to hear that
Experiment on.
we'll wait to hear that the go for catch has been sent.
You know, the boosters are now burning
Beautiful
already in
view
order
here
to keep
from
it
the
stable.
And so exciting to hear that we got a go for booster catch. That means it's going to be a really exciting morning. Again, the booster is making its way back towards now land in order to make that catch attempt in the tower.
So incredible to see these views. You can see the ship on the right-hand side of your screen. All 6 Raptor engines are under full power. Once again, the booster is making its way back to the launch site. We are going to try and catch it using the chopsticks on the launch tower, the exact same tower that it just launched from just, 5 minutes ago.
Yeah, and the booster.
Starship on nominal
And guys,
trajectory.
I can confirm the command was sent for the booster to come back.
That is
So I'm
incredible
looking
news.
up right now. It's pretty much right overhead of us, and we can see it starting to come down.
I can't wait for us to hear the sonic boom through Dan's mic.
Right.
That is going to be incredible. It was so cool to hear the liftoff. And so once again, it's successful on-time liftoff of Starship Flight 5. The ship has separated from the booster. The booster is there on your screen. It is making its way back to the launch site. We are going to attempt the catch using the chopsticks. We did hear the confirmation that the command was sent to the tower. We are go for catch.
And in order to.
And guys, we should just be about 30 seconds away from our landing burn. It's going to happen in 3
It takes
phases.
this kind of belly position, which is very important to ensure that it has the right position when it comes to the launch pad. Now it is in vertical. And of course now the boosters have to work very well in order to decrease the speed by which it crashes
You
down.
can see how fast this vehicle is moving on the left hand.
Here we go.
Landing burn has been ignited.
It's a very precise firing which is necessary. Not all the boosters, not all the rocket motors are working.
We can see those
Only some of them. Here we go now. This is the launch pad where it is caught by these arms and held in vertical position. This is an incredible situation. I mean, I couldn't believe my eyes. It has worked. The technology is there, and it was just a huge success.
This is absolutely insane.
It hasn't worked since. Two other launches have taken place. For one or the other reason it didn't materialize, but the 8th flight is now scheduled for the next days, and I hope we will see another successful catch. And this is a technology which I would love to see also. I would love to see also in the European Space Agency's rocket program, but we'll come to see that a little bit later. So now I have to see what is, So next topic was space debris. Space debris crashes on our front porch almost on a daily basis if we are not lucky. There is an increasing risk that space debris poses really risks for damage to material, to humans, to animals, to our infrastructure. We have two cases here which I selected. One happened in Naples in Florida in March 2024. A battery of the International Space Station has disintegrated in the atmosphere and crashed down without getting completely dissolved in the atmosphere. You see here the piece which has really then crashed through the roof of a house and has caused some damage. The other incident is basically here, which happened in Kenya on 30th December 2024. This is a huge metal ring which came from a rocket booster. It was a separation ring of a rocket which crashed down in Kenya on Makueni County. So the question is now, if anything happens, if somebody is hurt, if something is damaged, who pays for it? And there, the good solution is offered by space law. Space law provides for the possibility to recover the damage from the so-called launching party. The International Space Liability Convention foresees that the party which has launched this piece of hardware has to reimburse damage which has occurred on the Earth. So there is no problem basically to recover this damage. The only issue here in Florida is that it has been on American soil from an American launcher, which means that this agreement is not applicable. So these people have to look for damage reimbursement under US law. But in the Kenyan case, it is most likely an American rocket which has lost the separation ring. It might have damaged something on the infrastructure of this county, and the damaged farmer can claim damage from the US government. And this has to be done through the Kenyan government. It's not an individual claim you can launch. You have to go to your government in order to ask the government to address this issue to the, in this case, United States. Just to say that there is indeed the possibility to get compensation in case space debris damages something in your garden, front yard, wherever. It is, of course, also an issue which is considered by ESA, because we don't want that space debris is increasing in number and getting more and more dangerous. So we are trying to make our satellites more, let's say, resistant against being space debris in the end, which means that we want to shoot them into a so-called graveyard orbit in case they are reaching the end of the lifetime. In the end of the lifetime, the satellite's rocket motor is put into action, and the satellite itself will be put into an orbit where it doesn't pose any risk anymore and will not fall down to Earth. We also try to figure out how we can, in the orbit, grasp or catch dead satellites and bring them into a graveyard orbit. For example, through this kind of specific satellite which is able to pack this dead piece of metal and send it into this so-called graveyard orbit. So this is working, and ESA is working on improving this technology. The other issue which we mentioned as a kind of space news is that we have a new team in our European astronaut lineup. It is actually John McFall, who has been declared now fit to be a full servicing astronaut. He had a major issue on his right leg. He had an accident, and he had to undergo several operations before being able to get training for an astronaut, and he has actually succeeded to do it. In the end, he passed all the tests, and he is now certified to go on a long duration mission on the ISS. He is really an example for endurance and resilience. He is a certified doctor as well, and is now working as a full-fledged astronaut despite his handicap. The next issue was a problem with an asteroid which was becoming visible on certain space agencies' monitor. It was this 2024 YR4 meteor asteroid, which had a orbit which put it into a risk to crash onto Earth in 2032. Meanwhile, this has been reduced to below 1%, so I can tell you that this risk is not existing anymore, so we don't have to worry about this specific asteroid. However, in case it would happen, we have all kinds of means now to defend us. We have launched only recently the so-called NASA-ESA Planetary Defense Mission, which worked in 2 steps. First of all, we had a NASA DART vehicle, which was actually a big piece of metal, which was slammed into the asteroid, which we have chosen amongst many in the asteroid belt. And then we wanted to figure out if the orbit of this asteroid would have changed. And this was also a task of the ESA mission, which was called HERA, which has verified in which way the asteroid has changed his course. And indeed, we found out that the course has been modified, that the asteroid has really come off his course. I mean, this asteroid, which we are seeing here, was never a real risk, but we have used it to try out this kind of technology. So, to put a long story short, we know how to defend ourselves against an asteroid which is a real danger. So this is thanks to this planetary defense mission, which has a proven concept to tackle this issue. Going a little bit now to the mysteries of space, this is the first deep field image from the NASA James Webb Telescope, which is the successor of the famous Hubble Space Telescope. It was taken on 12 July 2022, and this is just an amazing image. You see in the forefront 8 stars, 8 objects which have this kind of spikes. And these 8 objects with spikes are in the foreground of the image. These are single stars, single suns. All the other objects you see in this image are galaxies. Believe it or not, they are all galaxies, and there are 10,000s of them. Just to give you an idea how many galaxies we have in the universe which could house also planets and Earth-like planets, and could mean that we are not alone. I mean, this is something we are always reflecting on. Are we alone in the universe? And if I see this kind of image, I always think that this cannot be the case, that we are all isolated. There must be something. If we have so many galaxies around us, so this is a great picture. This is a great image, and this is a verified image. This is not fake. Because and this brings us, of course, to several mind-boggling facts, which I need to tell you. After all, and this is also not fantasy, we have in the visible universe several 100 billion galaxies. There are even people who say we have a trillion galaxies, but okay, keep it with several hundred. In our Milky Way alone, we have 200 billion stars. This is in our galaxy, in our Milky Way. And thanks to the James Webb Telescope, we can now see light originating close to 13.8 billion light years away, which was actually the creation of the universe. Because as you know, if you look into the sky in the evening, this is all history. The light which you are seeing has been traveling for long time, millions of years sometimes, and the star which you are seeing there might not be existing anymore. You really look into the history. And the more sophisticated the telescopes became, the more we were able to look into the very history of our own universe when it started. And it is now confirmed that it has been a Big Bang. There's no other theory which holds stand. It has been the Big Bang, 13.8 billion 13.8 billion years ago. And now we know that this is true because we have the facilities to observe so far. So this has been confirmed. And look at the light speed, 300,000 kilometers per second. The same speed, by the way, for radio signals. And then how much is a light year? It's 9.4 trillion kilometers. And then look into the possibilities which we have today in order to travel into space, in order to leave the solar system. How can we seriously come anywhere in the not so long future, which is not in our own solar system? The next star, which is our neighbor, would be Proxima Centauri, which is 4.3 light years away. This is the nearest star. So light takes 4.3 years from this star Proxima Centauri to reach us, and vice versa. And Andromeda, this is our nearest galaxy, is 2.5 million light years away. It's the nearest galaxy. So the distances are just mind-boggling. They are in a certain way depressing because with what we have in our technology today, it is almost impossible to even think about leaving our little solar system and going elsewhere. The Milky Way is 13.6 billion years old. It's almost as old as the whole universe. The Earth is sitting where you have this little star, this little flash. It's a so-called Cygnus arm of the Milky Way. There's a supermassive black hole in the center of the Milky Way. And today we have discovered already 5,510 planets located in the Milky Way. This is something which we have found out. We don't see them through a telescope, but we know that they are there because there's a little bit of a deviation in the light emitted by a star when the planet crosses it between the telescope and the star. So this little deviation in light proves that there must be a planet. And 5,000 we have already discovered. Whether they are Earth-like, we have no clue yet. interesting also that the Earth is really so lost in space. I mean, it is so lost if you look at this pale blue dot image, really an iconic photo which was taken in 1990 by the Voyager 1 spacecraft. You see it on the upper left side. This is the image, and this is how the Earth looks like in this Cygnus arm. It was taken by the Voyager 1 spacecraft by simply turning it around when it was flying across the universe, if you wish, by turning it around and looking back to Earth. The camera usually shows in the other direction, but for the purpose of this picture, the scientists have turned it around and have asked to get this picture done. And this famous Voyager has traveled meanwhile 24.9 billion kilometers, and it's hurtling away with a speed of 61,000 kilometers per hour, 17 kilometers per second. I mean, this sounds an amazing speed. For me, this is incredible. So many years with this kind of speed, and still 1 light year distance will only be reached in 18,000 years. This is so depressing. I mean, really, we can do what we want. With this kind of speed, we are not going nowhere. We are not going anywhere. It is like that. There are possibilities to do so, but they are only in science fiction or in space movies. But this is how it is. They are traveling now since the 70s, this Voyager 1 and Voyager 2. They left the Earth system, the sun system with all the planets. They crossed the termination shock. They crossed the Kuiper belt. I mean, they did a lot of things. Now they are close to the Oort cloud, which is a kind of ice cloud which is placed here in this circle. This is their next point of reference. And yeah, this is something which doesn't encourage me to think about something which would help us to go somewhere in the near future. It's great to have these two ambassadors of mankind being around, that they fly, that they still send signals, there's still fuel, there's still atomic power in their fuel boxes, and this will last for another couple of years, but then they will just be dead and flying along. Right now they still show signals, Voyager 1 and Voyager 2. Yeah. Now we have this Andromeda. This is our next neighbor regarding the galaxies. It's 2.5 million light years away. I told light takes 2.5 million years to come to us. And the interesting thing is that the Milky Way and the Andromeda galaxy will one day, which means in 4 billion years, clash. They will fall into each other. This is proven. This is what we know because we can see this. So Milky Way and galaxy and Andromeda will join. There will be a joint galaxy. But don't think that there will be a big chaos. Don't think that there will be many collisions. The distances between the stars and the planets here in these galaxies, it's so huge that it is not expected that there will be anything like that there crashes between Milky Way and Andromeda galaxies. It will be more or less peaceful, but they will reunite. They will combine themselves. They will form one big new galaxy. Yeah, this is of course the typical question. No way that there will be travel because current physics doesn't allow it. Just to repeat it again, there is nothing in the current physical environment which allows us to make these kind of travels. There are two issues which are coming up again and again when it comes to possible solutions. One is the wormhole, which is actually a hypothetical tunnel through space-time. and time dilation. Time dilation is something which is existing already. We can prove it. It is just the difference of time passing between a person moving fast compared to what time does for a person which is standing on a firm point. So if somebody is traveling with almost light speed away from the Earth, he will grow slower old than the person which is still standing on Earth. This is this famous time dilation. It's a proven concept, but it only works if you are fast enough in order to make it really valid. Time dilation is good if you travel almost with light speed. Then you win a lot of years compared to the person which you left on Earth. And if you go to the Interstellar movie, you will see all this very well presented. I can only recommend it. Yeah, questions and answers. Where is all the life of the 400 billion stars, or roughly 4 billion sun-like stars? Where is all the life? Right now, we don't know it. Without faster than light method of travel, we won't be able to find anybody out there. If we are visited by UFOs, I mean, this is the same issue. How can these UFOs be able to travel so fast if they come from another, let's say, galaxy or another sun far away from ours? How can they do that? Do they really have a technology which allows them to do it? Do they come through a wormhole, or do they have time dilation? I have no clue. I think this is also the proof that the whole UFO story is just not realistic. It is just nonsense. If somebody wants us to visit from another galaxy, I mean, good luck. He will use a lot of time in order to come, unless he has finally a technology which we don't have. I mean, but we don't have it. And then, to heck with it, why can't we go faster than the speed of light, 300,000 kilometers, or at least go 300,000 kilometers per second, speed of light? Yeah, this is Albert Einstein. His theory of the special relativity. When a physical body approaches the speed of light, the matter's mass, or the mass of this object will become infinite big. And the energy required to go faster becomes infinite as well, which means that it is not possible to go faster. This is what Albert Einstein has found, and which has been proven in many experiments which have been performed. It is something which we cannot get away from. Going faster than the speed of light is just not possible, even not for the so-called UFOs. I mean, they also have to stick to it unless they found something really amazing as a new technology. So we are stuck a little bit. We are not able to go faster than the speed of light, and we are far away from anything which is in reach. So a little bit we are condemned to stay where we are for the time being, in our little sun system. We can go to Mars, but of course, this is really something we want to do. At least we should try to do it, because you never know how long the Earth will be still available. Because one day we might really use Mars to escape circumstances on the Earth which become not sustainable anymore. Now, this has been the part which deals with the mysteries. Now we go a little bit more in the daily space affairs, and we want to focus a little bit on the African continent, and we have space in Africa being tackled by the African Space Agency. It was created in January 2023. It has been already talked about many years before, but in 2023 it was finally inaugurated by the African Union. It is hosted by Egypt, and the headquarters are in Cairo, and as you can imagine, ESA has a mere coordinating role because it has no budget. Budget has always been an issue. They cannot do anything. They just want to coordinate the different space policies of the African Union countries. This is what ESA shall do. And yeah, I cannot really say whether it has been successful. I don't hear a lot of ESA, but somehow they coordinated that many launches of satellites on the African continent have been performed by countries on the African continent. 14 countries have already launched satellites, a total of 50. You see the countries here. South Africa has launched 13 satellites today, and this is the biggest number on the African continent. Congratulations. Then we go from the overall space agency in Africa to the South African Space Agency, SANSA. It exists already since 2010. The mission is quite clear: deliver space-related services and products to the citizens of South Africa, making their life easier. And activities cover Earth observation, space science research, space weather, space operations, and launch support. These activities are distributed over different locations in Pretoria, Hermanus, and Hartbeespoort. You see a little bit what is going on there. In Hermanus, we have basically here the space science research and education and space weather. Yeah, this is a little bit, only a little bit of what is going on at SANSA. People working here and being here, they might know much more, but this is the basics. Most recently, there was a major success with this inauguration of the sounding rocket launch facility at the Daniel Overberg test range. And this happened here. The Minister of Science being present, the first rocket already boosting into outer space. And yeah, this is a typical sounding rocket as it was present a couple of weeks ago, with Danny showing me this nice piece of hardware. Also very appreciated and very much of positive impact is the trainees and volunteer program. SANSA offers this for graduates and students, practical experience and opportunities for networking is guaranteed. People should just go on this website. And the picture is taken, I think, from the Antarctic station of South Africa. Now from the African continent, let's go briefly to ESA, so-called Europeans' gateway to space. We have 22 member states. We want to explore and use space for exclusively peaceful purposes. We have our headquarters in Paris, lots of sites in Europe, and we have a budget of 7.7 billion in 2025. This is not much compared to what is available, for example, at NASA. They have 25 billion in this year. But with this little money, ESA is doing, a lot of things, and a lot of good things, I have to say. These are our member states. We have also cooperation agreements with Israel, Turkey, Ukraine, and Canada. These are ESA locations, a little bit all over the world. We have offices and installations, and interesting, of course, here in Kourou, this is our launch pad. We have in Italy the Earth observation area for ESA. We have the headquarters in Paris, and we have a Brussels office. We are a little bit everywhere. We also had, or still have, an ESA office in Moscow and in Washington and Houston. So this is ESA all over the world. This is our budget. 7.7 billion in this year. And just to highlight maybe that the biggest chunk comes from the Earth observation department, which consumes the biggest part. Rightly so, because Earth observation and this Copernicus project is expensive, but it is so useful that every euro spent on that is not spent in a bad way. We need that. So this is why the biggest amount of money goes into Earth observation. Human and robotic exploration, these are our astronauts right now. You might recognize the one or the other name. If not, it's not a big deal, but you should know that we have a new team of 17 new astronauts, and this is also the team which now includes the astronaut with a disability. So out of 20,000 applications, ESA has chosen 17 new astronauts recently. Navigation. It's important to know that GPS is not anymore the only standard navigation system. Europe has now its own Galileo navigation system, which is available worldwide and which is under civilian control, which is of course important because GPS, the American system, is under military control and it can be switched off without any warning. So this is a risk. So Galileo has not that, it's a purely civilian system, and it's more accurate even than GPS. Today we have 32 satellites in orbit, 27 are operational, and ESA is of course the system architect of Galileo, and we built all the satellites and put them into orbit. Space transportation, you might have known the names. Ariane is our workhorse, it's still working. It's still working as Ariane 6 meanwhile. And we have a small launcher called Vega. And this is something which we are quite proud of. These are the two launchers which are very successful, very little launch failures, and very well appreciated by industry. Ariane and Vega. Ariane 6 is the one which is still now working. And Vega C is the latest update of the Vega rocket. And we have now a new initiative. I have to say, fortunately, the European Launcher Challenge, which foresees that ESA goes more into the private sector in order to ask startups and smaller companies to develop new technologies for launch vehicles. So this is a little bit the approach which the Americans have done when NASA has asked the private sector, please come up with new launch technologies. And this is where SpaceX came up. So ESA wants to go into this direction, and I really wish that this is a success, because we are still dealing with this old approach, which brings nothing but frustration. Even if the launches are successful, but these rockets will never come back. They can never be reused. This is not anymore what we should do today. This is not something we should continue to do. And as I said, ESA has to change its mind. And I think we are on a good way there with this European Launcher Challenge. And people start to get aware of the fact that we have to think differently. And now we go to this Copernicus. This is Copernicus. This is the Earth observation workhorse of the European Space Agency, which is available worldwide for everybody. It's a series of basically 6 satellite families, if you want. We have Sentinel-1, which is a radar satellite. We have Sentinel-2, which is an optical satellite. We have Sentinel-3, which is a bit of a mixture of both. Sentinel-4 looks only from the geostationary orbit into the atmosphere. And Sentinel-5 looks at the low orbit atmospheric conditions. Sentinel-6 is a altimetry reference mission. So these are the cornerstones of the Copernicus program. And all these Sentinels are being developed and deployed in a revolving mechanism, which means if one is out, there will be the second, there will be a replacement satellite launched immediately. So there will be never a lack of data. Data will be always available because the replacement satellites are already underway. Good for you to know is that you can access these data, which are available for everybody over a very long term, free, full and open. And this is the website which you please should open one day or the other in order to find out how you can access this data. This is something people don't know yet, but Copernicus Sentinel data are free for everybody. They don't cost a dime. It's important that people know that, and I really encourage you to go to this website one day, maybe even tonight. Yeah, these are the areas of application for Copernicus, quite vast, on land, marine, emergency, climate change, security. All this is covered by the services which are available due to the availability of Copernicus. We have here, as an example, we have here a refugee camp, which we have photographed and compared with the situation a couple of weeks earlier. So this is done almost on a daily basis. This is another example. The rainforest deforestation, it was in 2014 and 2016, and there you see clearly how the rainforest has been systematically diminished. It is a radar image from Sentinel-1. This is rainforest deforestation, and all these kind of measurements are possible with these Sentinel images. This is an optical image from Sentinel-2 from 2022 in March. And it was taken in support of Ukraine when they had to respond to this Russian aggression. So you see these yellow points and dots. So these are fire revealed by infrared photography. And this is, of course, something which then helps also the emergency troops to come and help. You see the name of Bucha here. This was the city which has experienced a very, very devastating attack by the Russian aggressors at that time. Then you have another optical image here, Sentinel-3. It's the dry matter productivity image of the African continent. And it shows in a certain way the growth rate of vegetation in that area over a certain number of years. And the more you see yellow, the higher is the growth rate. So you can easily imagine that this is, of course, outside of the arid belt in the north. And also in the south, there's lots of problem with arid and desertification. This is a Sentinel-3 optical image. Criminal activities can be followed up as well. Smuggling and all kinds of forbidden activities on sea. You see fast boats and skiffs that are most probably attempting to evade observation and sheltering from rough sea conditions. Yeah. This is visible here for those specialists who work on the images once they are available. This is a military deployment surveillance. This is in Syria on a certain day before the recent revolution there. You see on this image, the single helicopter or two helicopters, and a couple of weeks later there was a large deployment of Russian airframes in the same airport. So this can be, and also this infrastructure has been built. So this kind of information is available thanks to these imageries. Yeah, and at the end of my presentation, I would like to invite you to join this website if you would like to compete in the so-called Space Up competition, which is a global competition for startups, entrepreneurs, focusing on space-based solution in order to make Saudi Arabia more green. This is an environmental challenge. It is for all open. You just have to go to this website. There are millions of dollars available in prize money, and you just have to write something. You just have to give your opinion on an application which you suggest in order to help the Saudi Arabian government to make their country more livable. I think this is not too bad as just as an attempt for a young scientist or a startup to come up with this kind of proposal. Workshops will be organized in order to make things a little bit easier. So this is something I can recommend. And this brings me basically to the end of my presentation. I know that it has been a lot of information, a lot of maybe also technical information, which hopefully has not disturbed you too much. For me, it was a pleasure to repeat what I'm really concerned about, and this is our isolation in the universe, our lack of speed, which we apparently will have to suffer for a long time, but also the great, the great opportunity which we have thanks to SANSA and ESA and other space agencies, which make our life easier, which make our life better every day. You just have to look into it, what they are doing. So thank you very much, and I think if there are any questions, don't hesitate. Thank you.
I think you'll agree with me that that was a fantastic presentation. Thank you so much, Dr. Beer. We have some time for questions. I just request that you speak into one of our boxes so that our online listeners can also hear the question, and then we will give an opportunity for answer. You are allowed to throw them.
Yes, I'd just like to know who assigns orbits to satellites. If you launch a satellite, can you just launch it to any orbit? Or surely you have to take into account that there may be other satellites in that orbit.
Oh, yes. You just cannot just launch a satellite without informing an international organization about the expected orbit which you want to occupy. And only if this organization allows you to use this orbit, you are allowed to launch your satellites. Otherwise, it will not be approved. So there is always a process. I mean, launching a satellite is a complex issue. It's not only having the technology and having the launcher, you also have to be sure that you can put it into a certain orbit, because there are so many satellites now coming up. And this ITU, the International Telecommunication Union, she or he or whatever, it gives you the right decision on whether your satellite can go there. This is particularly interesting if you are in a geostationary orbit, where you are always keeping on the same spot, and if you would be too close to somebody else, there would be interference, the signals would be distorted. This would be a major drama. It has happened already, because people have not followed the processes. And there was drama, there were lawsuits, and it was not nice. As I said, it is regulated. That's a good thing.
Can I ask, how did Elon Musk get permission to launch hundreds of satellites that are now cluttering the astronomers' observation space?
I know. Elon Musk wants to launch about 10,000 of these satellites. It is, I don't want to say it's a drama, but it's really outrageous. It is typical Elon Musk, he doesn't care. It is not forbidden. As long as he gets the permits and as long as he has the financial resources in order to get them launched, he may do so. it is kind of polluting the orbit. You see these streams of satellites sometimes in the night, tens of them in one row. And you can imagine that this will continue over the next years or so, because he is far from being over. It helps it helps in certain areas. I mean, it has helped, for example, Ukraine. They have been able to tap on this information. He was able to open the Starlink line to Ukraine in order to defend against the attack of Russia. And also some countries on the African continent who are very difficult to be linked to the internet or to a satellite link, they might profit from this as well. And this is also why it was initially planned. Internet for everybody. This is what Mr. Musk says. Of course, he doesn't do it for free, but who is surprised?
Doctor, could you please explain how finding water on the south pole of the moon is going to provide fuel in order for rockets to then get to Mars?
This is an interesting question. It comes back to our chemistry classes when we went to high school. If you have ice, if you start a process which is called electrodialysis, this ice is separated into two components, which is on one hand oxygen, and on the other hand
hydrogen.
Yes, hydrogen. And this is, of course, is fuel. This is something which you win out of it. And this is why it is so important to find this ice. Without the ice, you will not make this chemical electrodialysis. You will not have these two components, and your rocket will not have fuel. It's as easy as that. And it's an easy process. There is a book which is called The Martian, M-R-A-T-A-N. It describes a mission to Mars which goes wrong. And there is one guy who is left on Mars, and he has to survive on the surface of Mars. And this book has been written by a former NASA guy. So it's very good, it's very realistic. And also this kind of winning fuel out of the ice which is present on Mars is described. It is something which is very well proven. Chemistry, lesson 1, high school.
You said that satellites that are finished are pretty much sent to the naughty step. Why aren't they just sent into outer space? When the satellites are decommissioned.
When the satellites are at the end of their life?
Yes.
Yeah. Well, there are two options. Either you send them into this famous graveyard orbit, which is very high, which will not allow this satellite to tumble back to Earth to make damage and to pollute the Earth. This is a graveyard orbit. But this requires, of course, a certain minimum of fuel at the end of the lifetime. The other possibility is to make it come down in a controlled way. This is what they did if there are huge satellites coming down. There was once a laboratory falling down. There was a huge satellite coming down which weighed 12 tons. And this can be done in a controlled way, which makes it coming down on the Indian Ocean and fall into the water. And all these emergency recoveries have worked. So this is a possibility. And I think this is what they are going to do with the International Space Station. Because I tell you what, the space station is nearing its end of life. In a couple of years, this space station is history, and we have to get somehow rid of it. And this can be only done through a controlled re-entry into the atmosphere. And this is what they are already working on. It's a huge element of metal. I mean, it's amazing. It's 3 football places of volume, which has to burn up. A risky business, but this is the only way to do it. We cannot send it into a graveyard orbit. This is not something which is considered. It's just too difficult. Yes?
I'm not clear on whether there's an overarching body for the globally. I mean, you talked about ESA and NASA and even SANSA, but Africa, but you know, for instance, the security, for instance, to prevent aggression, to do that orbit, to assign orbits and to sort things out if there is conflict. Is there a global body? And is it under the United Nations, or how does it work?
Yeah, well, this is of course a good question, because people are worried about all these possibilities, and they are also aware of what space can do. The United Nations has meanwhile own observation satellites. They can look into certain things and they can observe. This is the same for the European Union, which is developing these capacities for their own. The European Union also is now developing a system which is similar to the Starlink system, a kind of communication system by satellite that we don't want to be dependent on Mr. Musk's satellites. So there are issues which are getting done, but not on a global scale. I mean, except for this United Nations satellites which are already in use, there is no system which can be considered to be the bringing an end to a conflict or having a threat to the parties, telling them, if you don't stop attacking this country, we will make you suffer due to the capacities of our satellites which we have in orbit. We unfortunately don't have this yet. It is not feasible. We only have these national capacities, but nothing on a global scale. This will take some time, and if the United Nations wants to do that, they need to get approval of the member states. And I see already the big discussions at the Security Council or at the General Assembly by nations who will not accept this kind of approach, because big countries will not be willing to accept that there is somebody else who can deal with the conflict. This is how it is. It is a present political situation.
Isn't there a reluctance to allow technology into space that can go and capture space junk? Because that same technology can go and capture working satellites.
Yeah, this is something which is now really getting lots of attention also at ESA and at the European Union. They want to know how we can get rid of space debris or dead satellites which are already circling there, which we don't need anymore. It's good that we try to avoid to create more space debris by sending satellites into a graveyard orbit, etc. But what can we do with the existing stuff? And this is expensive. There are possibilities or there has been tests with huge nets which you can throw over a junk satellite and pull it away and make it burn up in the atmosphere. There are possibilities to laser items of space junk. All this doesn't really provide a solution which is promising, because this is cumbersome, this is expensive, and this is not yet in a stage where you can say, okay, we have a system which allows us to get rid of space junk, because we can just take a big magnet and tear them down and make them crash in the Indian Ocean. This system doesn't exist yet, but people are really worried about it, and they invest lots of money into getting into a technology which will allow it. They are working on it, I have to say. It's not that we are not doing anything. But I tell you what, it is easier to avoid more space debris than getting existing space debris out of the orbit. It is like that. There is no ideal solution yet on the horizon which gives us the impression that, yes, we can get the space debris away from us. It's like that.
Yes, sorry. I'm just curious about the asteroid that you said it might hits the planet in 2032, as you said. But you said they managed to decrease the impact rate to less than 1%. Then I was wondering if by any chance you know what was the percentage before that. I just want to see how far they can disturb the asteroid from hitting the planet.
You address the issue of the asteroid, where I mentioned that this is now under 1%.
Yeah.
Yeah, well, it's quite funny. There is an official scala, the how's it called? Astronomical Union. This scala ranges from 1 to 30 regarding the probability of an asteroid to hit Earth. Already, if it is over 3, there are certain alarm bells starting to ring, because 3% is a lot, because you never know what will happen in the next years or so when the asteroid is approaching. It can change its course, it can get moved closer to the Earth's orbit. So 3% is, according to this rule, already dramatic. Yeah. It has never been the case for this little asteroid. It has been always hovering about 2%, and meanwhile it is down to under 1%, which is of course so minimum that nobody is really worried anymore. But people get excited if it's getting to the 3%. The chance of collision with the Earth, 3% and higher. Nobody wants this, because there could be lots of deviation to the disadvantage of Earth, because it will still take years until this piece of junk, if I may say so, comes to this collision with Earth. So this is why they are very careful.
So if it was 50%, let's say, will be...
Oh, 50%?
Yeah. Wouldn't they be able to make it less than 1%?
50%, it means that it is almost inevitable that this will crash down. Then we can look for Elon Musk and a big rocket which brings us to Mars. Because 50%, nobody wants that. Please.
It's just in connection with the previous question that was asked. Isn't it like been tested by Europe, the ESA's mission of DART, I think? DART, yes. Yes, because it helps. It was, I think, successful in maneuvering a small part of the asteroid away from the threat zone. So couldn't that be done in order to avoid any danger of any asteroid coming too close?
Yes. Exactly. I think I hope to have told you that due to this successful DART experiment, we know that we can deviate an asteroid from its original path. We can just slam our DART piece of iron into this stupid asteroid and get it out of this, let's say, orbit which he has, because they are all orbiting. They are all in this orbit where we have all asteroids between Mars and Jupiter. They are all in that area. So now they come down and they get this hit by the DART mission, and we have proven that this deviation works, and only a minimal deviation is enough to get it out of the risky area. So to answer your question, yes, we don't have to worry at this point, because the DART mission has proven that we can escape the risk of an asteroid hitting the Earth, because we can make it, let's say, change its course due to our technology which we can bring up. So yes, we don't need Bruce Willis and Armageddon to put a nuclear device on this poor asteroid. We can do it simpler. We just have this crash effect, which it's quite brutal. I mean, the Hera mission has then shown the crater which was caused by this brutal impact, and it was amazing. I mean, this was huge, and we have also seen the product which was like an explosion blown out of this crater into the vicinity of the crater, and we were able to make out how is this asteroid made up, of which kind of minerals or ice or dust or whatever. So this mission was really great, and it was very recent, 2022, 2024. DART and Hera. Great missions. Every euro well spent.
Yes, that is true. Just one more question. It's just out of curiosity. Do you think, I want to know the legal aspect of using nuclear power to destroy or deviate the asteroid away from the danger zone so that we ensure the safety of mankind.
Yeah. Yeah, this is also a very relevant question, which came up already in the 1980s when Ronald Reagan devised his Star Wars program, which he wanted to put in place by putting nuclear devices into orbit around Earth, shooting at other rockets which are launched on the Earth's surface by laser, and this was a very futuristic approach. From a legal point of view, it was a lot of nonsense, because the current legal environment foresees that nobody may place into orbit a nuclear device, a nuclear weapon. This is just not feasible. It would have been forbidden under international law. It is the Outer Space Treaty of 1967, which says this quite clearly, because the founders of this treaty have already foreseen that this could have happened one day. However, it is not forbidden to send a nuclear device into space in order to destroy, for example, as you said, a celestial body, like an asteroid. This would have been possible because it's not put into an orbit. It doesn't stay there. It is used to get a danger for human mankind away. It is kind of self-defense. So this would have been allowed. There's no rule which forbids us to use this kind of nuclear device in order to, let's say, shoot down an asteroid. But as I said, let's use our DART technology. It's much better.
A question regarding the space debris that is still in orbit. There must be tons and tons. Oh. And I'm sure in the early days of spaceflight, it was not as well controlled possibly as it is today. No. So is it possible that there is no data available on some of the bodies flying around, in our universe?
Yeah. Well, there I can tell you that it is very much possible. These kind of little pieces, as of 2 centimeters, are all catalogued. It's particularly NASA and ESA have a well-functioning log book which catalogs all kinds of debris which is created. I still remember the day when a Chinese satellite was shot down, I think by the Chinese themselves, in order to test an anti-satellite weapon. And there was a huge cloud of space debris created in the atmosphere. What a mess, what a shit. I mean, people were really upset about it. It was such a pollution of the orbit. And until today, we have catalogued every little piece of this. The Americans and the Europeans, they have huge telescopes, and they see it. They can see these little pieces until 2 centimeters. I think this is a little bit the minimum they may have. And this means we are very much aware of where is flying what. And it would be also very bad if it didn't, because, the space station is still flying. We have lots of astronauts in there. And if we wouldn't be aware of a piece of space debris which would approach, then good night. This is not good at all. This is also why the space station is changing permanently its position. Nobody knows that. It's almost weekly. The space station ISS is either up moved or down moved with its rocket motors, because there is a little risk of a piece of space debris approaching. Nothing has happened until today. There's a great movie called Gravity. You have to see it. It's dealing with just that. It starts with a terrible scene where a big piece of space debris hits the International Space Station, kills astronaut, and it's just great. The movie is well done. Even our astronaut, Thomas Reiter, who is a well-renowned ESA astronaut with many flights, said he has never seen such good zero-gravity scenes in space, in cinema. Of course, nobody could go in space for this movie, but they have really achieved a very good simulation. I think they even made some zero-gravity flights, which you can do on Earth. You just send an airplane into a dive, and then you have 20 seconds of zero gravity. I did it myself once. I can't believe it, I did it. It was the so-called vomit bomber. The vomit bomber served just to train future astronauts. And we had 4 hours of flights, and we were having, I think, 80 of these parabolas flown. It was awful. I was so sick.
Well, all you
it's
need
horrible.
is minus 0.5 G, and you'll be floating.
It was a horrible experience because your inner ear will never manage to understand what's going on. And even pilots who were with us at that campaign, they got sick, and they were all sitting behind in the plane. They were hoping it will end, but there's no way that the pilot will stop because this is an expensive flight. There are only 3 or 4 pilots in Europe who can fly this because it's dramatic. It's a crazy figure. You go into a controlled dive and you fly with the airplane. Your body flies down and you feel like being really floating in space. I did this for 4 parabolas. Then I was finished. I was finished.
Okay, I just want to go back to asteroids or meteorites.
Yeah.
If one looks back at the Tunguska incident,
yes,
which wiped out massive areas.
Massive.
How accurate are they able to predict the point of impact of an asteroid or a huge meteorite?
Very much so. Today, they even know in which area an asteroid would hit if we discovered it already still in a very far distance, because our computers today, they can calculate so much and so exactly that we can even identify the area of the planet Earth where it will most likely hit. ESA does not publish this. They don't say where it would hit because they don't want to seed panic. But NASA has another approach. They say clearly, I mean, this is a risk that the asteroid will hit Columbia or, the area of this or that group of states. So they are more open. ESA doesn't want to have this kind of discussion, and they don't want to create panic. But today it is very much possible to let's say, identify the area of impact. Tunguska was too early. It is a long time ago, 40 years ago, something. It was a horrible event. Square miles of wood, of forest was flattened. There was nothing left. It was a horrible asteroid which has been hitting at Siberia at that time. Yeah.
I think one could probably manipulate property prices.
Oh, property prices immediately fell to another low in that area. Yeah. But as I said, today we have the means to identify these areas very early. And we don't need our famous actor, what's his name? Bruce Willis, to come. We have DART. So again, please note the email, the websites which I have indicated. If you're interested in downloading data, just do it. We will have available maybe the presentation for those interested, and they can read it and go to this website and start downloading images for free. Oh.
Once again, Dr. Leo, thank you very, very much. I want to just invite Renee up here as well, please, just quickly. Just want to hand over a small gift from SANSA.
Oh, no. Yes.
To you, just to say thank you very much for your time and sharing your
Darlene,
knowledge.
thank you very much. It is a pleasure.
Yeah, thank you.
It was a great pleasure. Maybe
Thank
we
you
can
very
repeat
much.
this one day. with another topic.
For our audience, sorry, Rebecca.
One will be good.
We'll share that photo. Thank you so much.
Thank you again.
To the audience members, thank you so much for coming out tonight. We really appreciate it, and we hope to have another one soon. And perhaps, Doctor, you can...
Oh, yes.
I should stand on my toes, yeah. And perhaps you can come back and share more knowledge about the legal issues, because I think that's also very fascinating. I think from the questions in the audience, I think that would be appreciated. So thank you very much for your time.
It's a pleasure.
And once again,
Thank you very much.